Okay, so we're going to talk about the syllabus for this class. The class times are set to be Sunday, Wednesday, 1500 to 1630, and we will start out online. That means typically you would watch the lectures before, and in the beginning we'll just touch base, see if there are any questions, and then go from there. It's not entirely clear how the delivery of the course will develop over the semester, but the main plan for now is to pre-record the lectures and maybe use the class time for some discussion. Not the whole class time, but maybe the beginning of the class time. So my name is Peter Wonka. My office is located in Building 1, but again, due to the current situation, I will most likely work from home most of the time. If you would like to get in contact with me, please send me an email. And in the following, you see the tentative TAs that will work on helping out with the course. And these names might change as we're doing the final preparation of the course, but that's the best guess for now. So I studied computer science at the Vienna University of Technology. I also spent some time in Grenoble and Rennes during my PhD. I did a postdoc at the Georgia Institute of Technology. I worked at Arizona State University as assistant and associate professor, and now I am full professor at KAUST. The research topics in my group are computer graphics and computer vision mainly, and then to a much lesser extent, I also work in remote sensing, image processing, and visualization. And the main work in my group at the moment is deep learning for visual computing. So we work on all sorts of topics. A lot of work is related to generative adversarial networks. We do 3D reconstruction, laser scanning, and several other topics listed here. Current plan is to use Blackboard and Slack, maybe Zoom for the meetings, but what we used last year was Blackboard, Slack. We might refine the tools as the class goes on a bit, but that worked out pretty well last year. We'll see how that goes with everything being online. So unfortunately, there's not really a textbook. There's this general deep learning book by Goodfellow et al. It's a very good description of several basics, but in some sense it's also outdated with respect to the state of the art, and there are probably some easier, simpler introductions in the sense that to get started quickly, this is probably a bit too complicated a book to read. There are several books. Unfortunately, I don't know one that I can really recommend because of the language. So there's one book that's Deep Learning with Python. That's an excellent book, and it's easy, practical introduction, but the problem is it's TensorFlow rather than PyTorch, what we will be using in this course. And also another book, Hands-on Machine Learning, is a really great book, a very popular book. It's, again, a very simple, practical introduction to a lot of machine learning as well as deep learning, but again, it's TensorFlow rather than PyTorch. And again, our course will be using PyTorch. The main goal for this class is that you should learn to implement deep learning algorithms for visual computing applications, and that also will be reflected in the grading, where your implementation and your ability to show something practical will be the most part of the grade. So you should improve your Python and PyTorch implementation skills, and then also you should learn the state of the art in research, or at least something close to the state of the art in research in some of the selected topics. Now, how is the grade determined for the class? The projects will be 85%. Each student has to work on 5 projects. All 5 projects have the same weight. And in addition to that, there will be assignments and quizzes worth 15%. In total, we'll plan to have maybe 10 to 20 smaller assignments, projects, quizzes, reading assignments. And then finally, there's participation. So for an online course, it's a bit unclear. In principle, participation doesn't really contribute to the grade. Only in extreme cases where someone does something that's very disturbing, that might be reflecting negatively on the grade. So late policy, so if you miss a deadline with justification, okay, if you have some very important reason, then we'll see, we'll talk about it. I mean, this will depend on the reason. You need some written documentation to state your case, and you should notify me as soon as possible. And then this is, if something important happens, we'll just talk about it. So otherwise, you know, we just maybe forget or you do something else. So late projects and assignments, there will be a penalty of 1 grade step. So for example, A- becomes a B+. And that counts only if you submit within 2 weeks after the deadline, and more than 2 weeks late work will be graded with 0 points. So there are 2 parts. One part is that you'll have to write a project that is correct. So the second part is that there will be a discussion about the project. So after submitting a project, you have to send an email to the corresponding TA and set up a grading appointment as soon as possible. Really, as soon as you submit, you have to set up this appointment with the TA. And the last possible appointment for anything to be graded is the last day of the classes. This is a requirement by KAUST and the registrar. And during the grading appointment, so you will have 1 for each of the projects, the grader will ask questions about the projects, including the provided code. So you should be able to prepare, to explain and reconstruct basically every line of the code. That means the project will not only be graded on how great is whatever you submit, but also how well you're able to explain the code. So even if your project is completely correct, but you cannot explain the code well or ask or answer questions about the code, you will not get full marks. Just some reminder about ethics. So one thing that some students might not know, it's not ethical to do some grade negotiations with your instructor because of some future plans or graduation, scholarships, some GPA that you need, and also just argue for grade improvements without merit in general is not considered ethical. Now, the main violation of academic integrity is something like cheating, fabrication. So typically, since the main product that you'll deliver is the code itself, the copying code from the internet or copying code from your colleagues is the most critical thing that we'll look out for. So you should be able to go and discuss the code, the project more with colleagues, but not in a line-by-line fashion, and not like share the code in the sense that you copy the code, you send an email to someone with your code. So the actual discussion that you have with your colleagues shouldn't be on a very detailed code basis. That means the code that you produce has to be your own, and it cannot be produced with like help writing the code directly. So we'll plan to do some checks, maybe even automatic plagiarism checks, to see if there's 2 or more students that basically submit the same code. Now, the attendance policy is basically unclear due to COVID-19. The first bullet points are whatever happened in the past. So right now, most likely there'll be online pre-recorded lectures that you're expected to listen to. Now, the skills for this class, the most important skill will be programming skills, and specifically we'll be using Python. So you should either know Python reasonably well by now, or you should have the ability to learn it really quickly. And it helps to have some initial experience with deep learning packages such as PyTorch, Keras, or TensorFlow. Just, it helps, but this is not something that we actually strictly require. If you would just be expected basically to start learning PyTorch a lot on your own to finish the project in this course. So we'll not spend a huge amount of time teaching PyTorch itself. So you should either maybe know that in the past. Not a lot of students knew that already, or be able to pick it up quickly. And you need the ability to write medium-sized programs, so not like 10 lines of code or 20 lines of code, but you should be able to debug and analyze medium-sized programs that you'll have to deal with in this project, in the projects. So also we expect some amount of machine learning and mathematics. I guess most importantly in mathematics is multivariate calculus, linear algebra, and some other mathematics used in machine learning. Optimization might be beneficial for a minor part of the course. So in the past, again, a lot of students could do the projects even though they might not have had a lot of mathematical prerequisites. Students could also attend the course if they didn't have any machine learning prerequisites. It's just if you come without programming, without mathematics, and without machine learning, this might be just way too much and way too overwhelming. But if you know 2 out of the 3, or you need to catch up on maybe 2 a bit, that's also doable. But in some sense, it would be good if you have some basic math knowledge, as basically taught in any undergrad degree, and some machine learning knowledge. Otherwise, you might have to spend some extra time, for example, reading some of these other, at least simple, practical introductions to machine learning, such as this one book, Hands-on Machine Learning with Scikit-Learn.